What I'm going to do in this video is walk you through the process of building an application in Java that is object-oriented. And what I've got here is a simple setup where we've got a couple of classes, and this is a setup that uses something that you'll read in your book called composition, where one class is composed of another class. In this particular case, we've got a customer which has an account. So whenever you see in a relationship between two objects the expression has a, you're looking at a relationship built around composition, where one object is composed of another. And that's what we've got with the customer. The customer is composed of an account along with some other things, but at least in terms of the customer and the account, they have that relationship. Now, if you look at the account down below here, an account has a method or member, a field here. Notice the minus sign meaning that it's private. And there's a customer here. So the account has a customer, and the customer has an account. So in that sense, they're linked together. Call it a one-to-one relationship. Now, it is possible, realistically speaking, that a customer could have many accounts. Let's say this were a bank, and a customer could open up a checking account and a savings account. We're not going to consider that here. We're just going to consider this like an account, say, at a department store, let's say. Let's say you go into Home Depot or you go into Sears or whatever, and you get an account with that store. Well, a given customer is only going to get one account at that place. So that would be a little bit more realistic type of a scenario that this diagram would help describe. So you got this customer, and the customer, these are the attributes or the things we need to know about the customer, what it exists or consists of. And a customer is made up of a name, an ID, and an account. Now, usually we like to break up the name into first name, last name, and we would want to put in things like a street, city, state, zip, a phone number, email address, and all of that. I left all that stuff out just to keep this example simple and not have to write too much code here. So I just put the very basic things in. So the stuff up here, these are all of the attributes of the class. Now the stuff below that line in this section would represent all of the methods or procedures, the activities or actions that this class is capable of doing once it becomes an object. So for instance, a customer, you could ask a customer for its name, and it returns back a string. You can set the customer's name by passing a string to it. It doesn't return anything back. It just does what you tell it to do. You can ask for the customer ID. It will give you back an integer. You can set the ID by passing one in, and it gives you back nothing. It just does what you tell it. You can get the account. Now, this is a typo here. This shouldn't say string. This should say account right here. But when you call getAccount, it returns an account back. If you want to set the account to something different, you can pass it into this method, and it returns nothing back. In Java, we refer to these as getters and setters, or more technically, a getter is called an accessor because you're accessing the field, and these are your fields up here. And then the set, whatever it is, would be called a mutator. Mutate meaning to change. So this particular method is capable of changing something, in this case the account. So we have accessors and mutators. They typically go together as pairs, although you don't always have to have both. For instance, if you have a case where you have a read-only property, like a password, you may have a get password property but you wouldn't have a set password. Or you could look at it the other way and say, we don't want you ever to be able to know what the password is, but you can set it or change it if you want, in which case we would not have an accessor, we would only have a mutator. So we'd have a set password with no get password. So they don't always have to come together, although they typically do. Now, the first procedure up here is a constructor. You know that because of the name of it. The name of a constructor matches the name of a class, and then there's no return type specified at the end. Now, the purpose of a constructor is to initialize your soon-to-be object with data. And you can create the object with one line of code. Using this constructor, you can pass in the name, the ID, and the account all at once, and it will handle it all for you. So that's a constructor. And then we've got our getters and setters here. Now, looking down at the account has a customer who owns the account, and then there's a balance. Now, you can create the account. Again, here's a constructor. You can pass in the customer and a starting balance. You can get the customer, and you can set the customer. You can get the balance, or you can set the balance. Now, sometimes you will see in a definition for a situation like this, the designer will say, no, we don't want you to implement a set balance. You can ask for the balance, so a get balance is fine, but the only way we want that balance to change is if you call deposit or withdrawal. So you can't just go up to the account and say, oh, you now have $3,000 in it, or say it was $1,000, and you say, oh, now you got $3,000. Now, what you'd have to do is you'd have to call the deposit method and pass $2,000 into it, and it would add it to the existing $1,000 to come up with your $3,000. So depending on the purposes of the program, where the class is going, and the overall architecture of the program, you may notice things like that. And there generally are good reasons for excluding certain types of procedures inside of a class. The idea behind deposit and withdrawal is you pass an amount to these things, and they put the money in or they take the money out. They don't return anything back to the caller. You could very easily modify that so that they could return a code, whether it succeeded or not. So in other words, if you say you took out $1,000, so you call withdrawal and you pass $1,000 to it. Well, what if the balance was only $500? Well, then you'd be overdrawing it. Now, if overdraws were acceptable, that'd be fine. But if they were not, then you'd be taking out more money than you had, and that would not be possible. So then in that kind of a situation, what do? Do you just ignore the request? Do you take out as much as you can? Do you just put up an error message? Well, one possibility is to return back an error code so the user can call withdrawal, and if it comes back, 0, it failed, and 1 meant it succeeded. So you could do something like that. And we could go into all of those added details today, and I'm sure you could think of many more, but I don't really want to do that in this video. I want to try and keep things simple this time and just create the bare basic structure, which is really what chapter 3 and 4 is all about in your book. And now, if you took CO117 and you used the Pharaoh book and you went through chapters 3 and 4 already in that course, the reason we're doing them again in this level of detail is because they were rather intimidating chapters for the intro course. And we want to make sure everybody understands these chapters well, especially in this course. And so I'm going through them again in detail. So for some of you, this will be review, and you'll already know all of this. Hopefully for most of you, this will be review, but it'll be a really beneficial refresher for you because there may have been some things you weren't quite clear about. And then there may be a few of you who took 116 and you didn't learn Java and you didn't learn anything about classes and objects. So this would be your first exposure to that. And our goal here is to try to find a middle ground that meets the needs of all three of those type of students. So that's the purpose that we're going through these chapters 3 and 4 here at the beginning in some detail. So what I have here is IntelliJ IDEA, and I've set up a project called CO117 Summer 2015, and this folder is on a Mac, and I have my root directory, and I have a folder named IDEA Projects, and then this is the subfolder where this project is going to go. And so what I'm going to do is expand into this, and you'll notice that in IntelliJ, it creates a folder named SRC. Now, if you run Eclipse or NetBeans, they work the same way, and that is you create a project, and you put all of your files into that SRC folder, and then when you're ready to test or run your application, it compiles all of the files in the SRC folder and puts them into another folder called out. And the out folder is where the compiled code resides, and it actually executes out of that folder. So they keep them separated just to make it easier to maintain everything. So in here, if I want to start out building something, what I do is I right-click on source there on SRC, and I select new Java class. And it asks me for the name. Now, this class that's going to be created, what's going to happen is it's going to create a file. And this class is going to be public, and it's going to have a main method. So it's really the entry point of the program. So I don't want to build my account or my customer class quite yet. So what I want to do is build a test program, which we often call a test harness, to allow me to create these objects and try them out. So I'm going to create a class here called Bank Manager. So Bank Manager is my testing class that will exercise the other two. So what I'm going to do is I'm going to select OK here, and it will create this class for me here, as you can see. And you'll notice that it is a public class. You'll notice there's a file name up here named bankmanager.java. Now, in Java, a public class must reside in a file, and the file name must match the name of the class minus the .java extension. So the first part of the file name must exactly match the name of the class, including the case of the terms. Now I can add more classes to this file as long as they're not public. So I can come in and I can make a customer class, and I can make an account class. Usually it's better to not do that. Usually it's better to put each class into its own file. That way, if you want to share that particular class with someone else, you can do so. You're not going to give them all of this stuff if they just want one piece. For the sake of this course, if we were to put these three classes into three different files, then when it would come time to submit this, you would have to zip up the three files and send them to me that way, or you'd have to attach each of the files separately. So for this class, I wanted to try to keep things simple and have it so that you only have one file that you have to give me. And the only way that we can really do that is to have it this way, where you've got one public class and then other classes that are non-public in the same file. So what you do is that is at the top, you put in your comments. So you'd start with the title of the program and the author, the date you created it, and then some sort of a description, that tells you what the program is. And so I'll put here a space, and I'll put something like this. This program demonstrates the concept of composition, as well as providing a helpful yet simple example of creating classes and building objects from them in a testing class that is public. So I don't know if that description, it's just a description, and hopefully this will help make sense of what's going on here. But the other thing for you guys, you'd want to put your course up here. So CO117 summer, and the section number, I can't remember that off the top of my head, 7772 or 3 or something like that. Whatever it is. Anyway, put that in as well. So that would be the comment. We call this a comment block. And so one of the things you're going to always want to do is add to your program a comment block at the top of each code file that you submit. Now, usually you'll only be submitting one file, and so you just put that up at the top. Now, the public class should have a main method in it. Now, because this is IntelliJ, I can type in PSVM, and I can hit the tab key, and it will complete the syntax for this. Or you can just type it all in yourself, but it's public static void main with the args string array coming in. And then I'm going to put a comment here. Create a customer, an account, and hook them together. Test the account class methods and verify they work properly. Oops. Okay. So those are to-dos. And usually what I'll do is I will put the to-do comments in everywhere I need to implement code, so that when I'm really finished, I won't see any to-do comments anywhere. So I would put one here, and I'd put one here. And if it was the end of the day, I would save it, check it in, and then the next day I came in, I would start building whatever I wanted to, but I would at least see, okay, I've got 4 tasks here that I need to accomplish. So let's start with our customer here first. Now, generally what we do is we create we put in the fields first. Now, fields are always declared private. And I have 3 of them. So those are my fields. What typically comes next is my constructor. So public customer. I'm going to take a customer name, an ID, and an account. Let's call it, well, I guess I should spell it out here. Account. So that is my constructor, and we need to fill that in, which I'll do shortly here. Now, I need to build getters and setters for name, ID, and account. And rather than typing all of that stuff in, I can use IntelliJ to do that for me. I can right-click on name, and I can select Refactor. And I'll bet you this is going to go off the edge of your screen. So you know what? I'm gonna go ahead and scroll up a little bit so you can see this. So I'm going to come up here and right-click on name. Go down to Refactor, and it says encapsulate fields. What encapsulate fields means is to generate getters and setters for your fields. If I click that, it presents me with the 3 fields. It notices that I happened to select the name, so it checked that one. But it also shows the other ones. Now, for name, it says, do you want to implement a getter and a setter? And I can check or uncheck or whatever, any combination of those. And then the visibility down here, the field is private and the accessor is public, and that is the default. All of these defaults are great. And so basically what I'm going to do is just check all 3 of them. And I'm going to hit Refactor. And it's going to build all of those getters and setters for me. And all they're doing, if you look, for instance, at get name here, it returns the name. Now the name is the private field. It's a variable, but it's private, so you can't see it. But what you can do is you can see get name. And get name will return the name field for you. I always use kind of a goofy analogy, but it seems to work all right. If you pictured your class as a bar, and this field right here was a person in the bar, it's set private. So that person is inside the bar. You don't know he's in there. You can't see through the walls of the building. So it's private. What you can see is get name. Well, get name is our bouncer. He's standing at the door. You can see him. He's public. You can go up to him and you can ask him for this quote-unquote person, and he is returning that person too. He's making it visible to you so you can see the person. It's kind of like you're asking to see the person, and he takes them and brings them up to the door and shows them to you. And you can interact with the person. Now, set name would be used if you want to change that quote-unquote person inside to something different. You pass in what you want it to become, and the bouncer takes that and sets it into the private variable inside using this.name. Now the this speaks of the, using our analogy, the bar that you're currently working with. If you had 6 customers all running at the same time, using our analogy, if this customer class was a bar, then you'd have 6 bars out there. We're only interacting with this bar, not all of the bars. So when we see this .name, we're saying, okay, set the name for this particular object we're calling a bar, just this one only, not all of them, just this specific one of them. We want to change the name for this specific one only. So if you have 6 customers and you want to set the name, you're only setting the name for one of the 6 customers, not all of them. That's the purpose of the this keyword. So this.name equals name. Notice now, this name is white and that name is blue. If you look up here at the field descriptions on line 23, where the name is declared, notice it's in blue up here. And then notice in this method, the parameter that gets passed in is white. Those are 2 different variables. Think of the bouncer, right? There's a person already inside. That person is in blue. You're bringing a person up to the bouncer and saying, I want him to go inside. Well, he's the white one. If the bouncer just blindly accepts whoever you give, he kicks out the blue one and replaces the blue one with the white one. So basically, the white one becomes the blue one now. And whatever was there gets kicked out. So the old name is out, the new name is brought in. No questions are asked. You can ask questions inside of these setters. For instance, if you had an age, you had a get age and a set age. And somebody came along and wanted to set the age to -10. Well, guess what? The bouncer's going to look at that and say, I don't want to do that, and throw it out. And a simple if statement could do that for us. Now, we're not going to worry about that yet, particularly for this video, but be aware that's a very feasible thing to do. All these getters and setters blindly return and set whatever you tell them with no questions asked. Generally, that's not always a good thing to do. But to keep it simple, we're going to leave it that way. Now, going back to our customer then, we can simply call our setters here. Oops, I spelled that wrong. That should be int. So we just simply take name, ID, and account, and we pass each one of them into the appropriate setters, and they take it from there for us. I could have put this piece of code on line 42 where line 29 is. Then I could have put line 52 where line 30 is, and so forth. Why don't I do that? Well, because if I do that, I'm duplicating code then. You might think, well, what's the big deal? Well, if I wanted to make a change to this line 42, because I would have duplicated it and put it also up on line 29, I would have had to remembered that if I change it here, I have to change it up here as well. It's usually always a bad idea to duplicate code. That's why we make methods, and that's why we call the methods. So customer doesn't do the work, he just calls the method to do the work for him. So if you ever needed to change something, you just change it in the method. But this up here never has to change. It's a good programming practice to get used to doing. Never duplicate code, ever. So this is our customer class. That's complete at this point. Let's take a look at our account. So we know that we want a customer. We know we want a balance. And we want a constructor. And we'll make our balance a double because obviously it's money we're dealing with. And we want to include the dollars and the cents in this thing. So I'm going to stub out this method when we call stubbing it out. What I mean is I put a to-do there and I get back to it later. And then I'm going to right-click on customer. And again, I'm going to go down to Refactor and encapsulate fields. I'm going to check both of them. Hit Refactor, and that gives me all of the stuff that you see from here down to here. This block right here. Only thing we don't have yet are the deposit and withdrawal methods. So I'll have to do those myself. Public void deposit. And then my withdrawal. So I'm going to put in a little bit of a sanity check for these. So I'm going to say, look, if for depositing, if the amount is greater than 0, then I'll go ahead and proceed here. And what I'll do is I'll take the balance and set it equal to itself plus the amount. So I'm only going to do the deposit if the amount is greater than 0. Otherwise, you would actually be taking money out if the amount was negative, which would violate the purpose of the method. So it's a sanity check. Likewise for the withdrawal, the amount has to be greater than 0. And if it is, then I take the balance and I subtract the amount from it. Now I'm not worrying about overdrawing here. Certainly that's an issue. Some bank accounts let you overdraw up to a certain amount. Others don't. Some have different policies based on some sort of a privilege level or a status or whatever. For us, we're just going to allow it for right now to any amount. Again, probably not realistic, but we can always change that later. I don't want to get into all the details for this example again because I'm trying to keep it simple, for this program. Now, IntelliJ oftentimes will give you suggestions. This little light bulb comes on and it's saying, look, you can remove the braces from the if statement. And it says that because there's only one line of code in my if statement. I really don't need those curly braces. And I usually like to keep them there anyway because then if I ever have to add more code, I don't have to put the braces in later. I also find that it just makes the code for me a little bit more readable. but that's just my own personal preference. But it gives you that advice, and that's one of the things I like about this tool. It's smart about what it posits as a comment or as a suggestion. Well, we have a simple account here that can withdraw, deposit, report out a balance. So let's see. We haven't done the constructor yet, so I'm going to go ahead and do that a second. Okay, so I've got my two statements for that. And at this point, there are no to-dos except for the top part. So let's see what we've got. It says create a customer, an account, and hook them together. So let's start by creating our customer. I'm going to create a customer called C. It's a new customer. It needs a name, an ID, and an account. Well, I can give it a name. I can give it an ID, but what about the account? Well, I could create a new account right here. But it wants a customer, and I haven't created the customer yet. So we've got a little bit of a problem, don't we? Kind of a chicken and an egg problem. So what I'm going to do is I'm going to comment this out, and I'm going to create the account first. And I'm not going to use, well, forget that. Let me just back this up. Okay, it wants a customer, okay? Now, I don't have a customer yet to give it. So that's okay. I just have to put null in for the customer and give it a balance of 0. Then I could create the customer, and when it wants the account, I could just pass an A to it. So that's one way I could do this. I could create the account first without a customer. Then I could create the customer, pass it the account, and by doing that, the account will then be associated with the customer. This just seems a little bit weird, doesn't it? Let's think about this realistically, okay? You walk into a bank and you come in and you say, oh, I want to be a new customer at your bank. People say, cool, let's set up an account for you. Well, why do we have to set up the account? Why can't, when we create the new customer, let that class create the account for us? So in other words, what I'm saying is this. If I go into the customer class and I look at its constructor, the constructor says, give me your name, your ID, and an account. What we're saying is, look, we're a brand new customer. We don't have an account. Why don't you do that for us? Well, we can do that. So what we can do is we can take out the account piece, and then right here, instead of saying set account, we can say account equals new account. It wants the customer object, which we can type in this. And it wants a balance. Well, if we put the balance up in our constructor, then all we have to do back in there, our main method, is create a customer. When we create our customer, we pass it a name, an ID, and a balance. the customer creates the account for us, passes our balance to it. So we don't have to create an account and then a customer. All we have to do is just create the customer. So let's go back up here to the main method, and I'll show you what I mean. I'm going to get rid of line 17, and I'm going to say here with customer C here, create a new customer, and it wants in fact, what I'll do is I'll erase all of this and go like this. It wants a name, an ID, and a balance. So there's our name, our ID is 1, and our balance, we'll put $1,000 in our account for an initial balance. So we now have a customer, and we have an account for that customer. Can we verify that this all works properly? Well, let's try that. If I go to my customer, notice now all of the methods that I can call. I can set some things, I can get some things. What I want to do is I want to get the customer's account. And then what I want to do with that account is I want to deposit $500 into it. Then what I want to do, I'm going to type S out and hit the tab key, and it gives me the system.out.println, and I want to say the balance is now, and I want to put here the balance. Now I'm going to make a change. Instead of using println, I'm going to use printf to apply formatting to this line of text. What you do with this printf statement is you put in your text, and when you want to show a number, you put a placeholder in, starting with a %sign. Now, because this is a double or a floating point number, we use %f. And if I only want to see it, the number rounded to the hundredths place, then I say 0.2f. So it gives me 2 digits to the right of the decimal. And if I want to put a $sign in front of it, I just can stick a $sign there. So that's how you display monetary values. You use printf, and you use that as a placeholder. And then at the very end, inside the parenthesis, but after the comma I just added, again, I get the account, and I call get balance. Now, printf does not add a carriage return. So I'm going to put a \n, and not a /, but a \n, and that will cause the cursor to go down to the next line. Now I'm going to get account, and I'm going to withdraw 100 out. Now, line 21, see how I'm duplicating it, right? And as I said earlier, you never want to duplicate code. So let's take and turn this into a method. We'll call it print balance. And I'll put that line of code in. Now, it doesn't know what C is. So I have to pass that into the method as an argument. So now what I can do is on line 21, I can say print balance C like that. And I can do it again on line 23. And then instead of duplicating code, I eliminated that problem. Now you might be saying, well, you're still duplicating code. You're duplicating these 2 lines of code. Well, that's true. Strictly speaking, I am. But these 2 lines of code call another common line of code. So this duplication is acceptable. This is the one, because if I was going to make a change, I wouldn't change these 2. Likely, I would probably just change this. Another thing I'll do just to help out the user here, I'll just put adding 500, subtracting 100. And then the last thing I'm going to do, just to test that everything works, is I'm going to print out the name of the customer, the ID. I guess that's really, well, yeah, that's really all there is. That's all there is to show other than the balance. So, and that's all just there for testing purposes. So let's run this thing and see what we get. So I'm going to go up and I'm going to right click and I'm going to say run bankmanager.main. So it starts out with $1,000 and I say I'm adding 500 and now it shows a $1,500 balance. Subtract 100, it shows it as 1,400. It prints out my name properly and my customer ID is 1. So everything appears to be working right. One other thing it might be interesting to do is to print out the balance before I do anything to it. So if I add that line of code in, it just gives me that additional line there. So I know it's 1,000 to start with. I add 500, it's 1,500. I take out 100, it's 1,400. So the program's working fine. Everything looks good. I've got my program is commented as well as it needs to be. And there really isn't anything special I have to say down in here, so call this program good. So again, this is a situation where you have composition because you have a customer class that has another class as its member, as a field member. And that's what they mean by composition, where one class uses another one. Now we'll be talking about inheritance, and that's where one class is derived from another class. It's a little bit different concept. And we'll use this example to illustrate that in a future video. But we're good on this one. I'm going to wrap this one up. Thanks for watching. We'll see you in another video soon.